Welcome! Today we will be talking about t-test, specifically t-test for uncorrelated means. Before we begin, we must set a topic learning outcomes. After this session, the student should be able to know when to use t-test for uncorrelated means, use the given formula to test the hypothesis, understand how to interpret the data and come to a decision. Now let me give you a brief introduction about t-test for uncorrelated means. The t-test for uncorrelated means or independent sample t-test compares the means between two unrelated groups, independent sample on the same continuous dependent variable. For example, you could use an independent sample t-test to understand whether first-year graduate salaries differed based on gender. Your dependent variables would be first-year graduate salaries. Your independent variable would be gender, which has two groups, males and female. Here are the formulas that we will be using for this topic. Main formula is T equals mean of the first group minus mean of the second group over the square root of variance 1 over n1 plus variance 2 over n2. Below are the formulas for variance and summation. Let's go to our first example. Given our table, is there a significant difference between traditional and simulation teaching based on the student's scores? We need to get the null hypothesis, degrees of freedom, CV and TV and decision. Given that the level of significance is 1%, let's proceed to solving. First, let's find the mean of x sub 1. Note that n sub 1 is the number of variables under x sub 1. We get 29.9. Note that n sub 2 is the number of variables under x sub 2. We get 31.4. After that, let's try to substitute the value and fill up the table. Let's assume that we've already finished substituting, so now let's fill up the rest of the table. After that, let's take the summation of the square of the difference x sub 1 and mean of x sub 1, which is 616.9. And the summation of the square of the difference of x sub 2 and the mean of x sub 2, which is 830.4. Now let's substitute value using our formula. We already have all the values needed except for our variance 1 and variance 2. So let us solve for variance 1. Using the formula summation of the square of the difference x sub 1 and mean of x sub 1 over n sub 1 minus 1, we get 68.54. Now solve for the variance 2. Using the formula summation of the square of the difference of x sub 2 and mean of x sub 2 over n sub 2 minus 1, we get 92.7. We get negative 0.37, but we should only take the positive, so our computed value is 0.37. So how do we get the tabular value? You can use the t-distribution critical values table. We are using the 1-tailed and 1%, so use 0.01. Now use the degrees of freedom 18. Our tabular value is 2.552. So we now have to decide. Always remember, HRLA, higher reject, lower accept. When the CV is higher than TV, the null hypothesis should be rejected. When the CV is lower than the TV, the null hypothesis should be accepted. So we can now answer the question. Our null hypothesis will be there is no significant difference between traditional and simulation teaching based on students' score. Our degrees of freedom is 18. CV is equal to 0.37 and TV is equal to 2.552. Since 0.37 is lesser than 2.552, this means the CV is lower than the TV, so the null hypothesis is accepted. There is no significant difference between traditional and simulation teaching based on students' scores. Here's another example. Is there a significant difference between physics and chemistry based on the student's grade? Still, we need to get the null hypothesis, degrees of freedom, CV and TV, and decision. Given that the level of significance is 1%, let's proceed to solving. So our mean of x sub 1 is 86.4. And our mean of x sub 2, 86.33. Let's fill up the tables. We get 225.2 as the summation of the square of the difference x sub 1 and mean of x sub 1, and 147.34 as the summation of the square of the difference x sub 2 and mean of x sub 2. Now we proceed to solving for variance 1 and variance 2. Like we did a while ago, substitute the value using the formula. So our variance 1 is 56.3 and our variance 2 is 29.47. Now our values are complete. Now let's get the computed value. Using the formula, we get 0.17 as our computed value. Using the table of values, our tabulated value is 2.821. So we can now answer the question. There is no significant difference between physics and chemistry based on students' grades. Degrees of freedom is equals to 9. CV is equals to 0.17. TV is equals to 2.821. So since CV is lower than the TV, the null hypothesis is accepted. There is no significant difference between physics and chemistry based on students' grades. For the last example, you should try it yourself. Is there a significant difference between men and women based on their shooting scores? Give what is asked. Feel free to pause the video if you need more time. Now check your answers. Your variance 1 should be equal to 30.21. Your variance 2 should be equal to 19.99. Solve for the CV and you should be able to get 42.94. Use the table of value and you should be able to get 2.624 as your tabular value. So here are your answers. The null hypothesis should be there is no significant difference between men and women based on their shooting scores. Degrees of freedom is equals to 14. CV is equals to 42.94. TV is 2.624. So your CV is higher than the TV. This means that the null hypothesis should be rejected. So your statement should go like this. The null hypothesis is rejected because CV is higher than TV. There is significant difference between men and women based on their shooting scores. Did you get the answers right? If you did, that's great. If you didn't, then you should try to rewatch our video and try again. That's all for today. Thanks for watching.